Hello, I am Yoav Kabanchik and from the Hebrew University of Jerusalem, and I will be talking to you about how diagnostic tests in the past have saved humans from plagues. This is particularly timely as we are facing today this corona crisis and looking for both new diagnostic tools and new ways to perhaps immunize patients. And I think there is a lot we can learn from the past, how it all started regarding diagnosing some of the most severe human diseases that cause terrible plagues, and also how to cope with them in a very original way. And that's the start essentially of vaccination as we know today. And I will start by quoting Arthur Schopenhauer. Arthur Schopenhauer, great philosopher, had some very interesting idioms that he praised in his books. And one of them said that talent hits a target that no one else can hit, but a genius hits a target no one else can see. And we don't see the causes of these diseases, many of them with our own eyes, or very difficult in real time to follow them. And the question is, how do we target something we cannot see? And let's see how they cope with that in history. And we will start a few years ago, many years ago, in fact. Um, we're talking about 1803, the end almost of 1803. From the port of La Coruña sails a boat somewhere to somewhere, and the name of this particular voyage is referred as the Royal Philanthropic Expedition, which was a royal supported, sponsored voyage to essentially save the dying colonies in South America. So from the northwest of Spain sails a boat across the ocean to save these colonies in South America. The group will spread north and south, and then later even cross the Pacific Ocean to reach the Philippines, cover part of Philippines and the southern part of East Asia, and return back to La Coruña. Now, what was the basis for that is that there was a cry for help from the colonies that were getting devastated. The whole thing started, in fact, with the invasion of America and the colonization by the Spaniards, who brought with them both the cross but also some diseases that the locals were not exposed to, and caused their havoc and terrible loss of people. More than 90% of the indigenous population perished due to smallpox. Many of them remained blind or with scars in their face, those who managed to overcome the disease. That was extremely painful also to see them dying in relatively fast time after contracting the disease with absolutely no help. 90% gone in 50 years, and this trend in fact continued and continued for quite a while until almost the 18th, the 19th century. In the meantime, also the British took advantage of this observation that the local people were very sensitive uh, to this type of infections, and they on purpose infected the blankets with the smallpox, distributed to them as gifts, and essentially exterminating tribes. This is it's an old tactic which has been used even by Genghis Khan, but incredible to see how a genocide has occurred by so-called civilized nation. Now, the Royal Philanthropic Expedition was sponsored by the King Carlos IV. He was in serious trouble with France and in England, fighting wars over the predominant, over who is going to be ruling the seas. He lost a lot of his people and his fleet. But nonetheless, he decided to sponsor this philanthropic expedition because he was losing the colonies, and he needed their support, economic support, but also because in his own family, his own child, facts succumbed to the smallpox. So it was for him also a philanthropic type of a attitude that he had. And he sponsored it. It took almost a year to make all the preparations. And so what we are going to see as this voyage is a very peculiar one because it was a relatively small group of people in the boat, not more than 30 people, the professional team about, and less than 10 in the crew. That consisted of was comprised of the head of the mission as Dr. Balmis, who was a physician, and his assistant, Dr. Salvini, but also two medical assistants that were there, three nurses, and headmaster of an orphanage home. And she actually accompanied 22 children that were selected from different orphanages in the northern part of Spain. They were between 3 to 9 years old. All of them were naive, were healthy, except of one of them that, on purpose, was infected with cowpox. And I'm going to refer to why this was done in a moment. They had no special equipment except for some needles and scalpels and some cloth that they used instead of cotton or gauze. And 2,000 just small slides for basically keeping serum that they will take from different patients. And 500 copies of a book. In fact, it was a manual for vaccination written by Moreau de la Sarthe, who essentially translated a paper by Edward Jenner and expanded the work there to make it more practical, for practical use, about the methods that were described by Jenner himself. And what was the idea? The idea there behind all that is that the children were the carriers of the vaccine. So one child was already infected with the cowpox. This causes a minor symptoms, and especially what they had is a type of a pustule or a pox or a scar there that was very typical to cowpox. And so the idea was after being infected between 7 to 10 days, this liquid form of the pus of the serum from this scratch or pustule will be withdrawn or absorbed in a cloth and transmitted to another child. And the child, the new child, will contract now cowpox, and in 17 days he will be the donor to another child. And the idea was to cover within the 3.5 months or so that they expected to have the entire expedition reaching the America, to at least one of the children there be infected so they can continue the inoculation of the cowpox, with the idea that this cowpox is going to protect them from the severe disease called smallpox, which was causing havoc in South America and in North America, part of North America as well. So all that was based in fact on a previous publication by Edward Jenner, who was a very meticulous observant of what the people were contracting in the area that he was practicing medicine. He was a country doctor in the Gloucester, in the Berkeley area in England. And what he noted is that milkmaids that were contracting a particular type of pox, or so-called cowpox, particularly in their arms, from the cows that they were milking, and they are the ones that usually contract this disease or get this disease. So that's the reason called cowpox. In fact, the natural history of the disease was very interesting for him, and he described that those are his original drawings. And he found that up to 9 to 10 days, there is an increase in the size of the wound that then slowly and gradually decreases. But he also observed some other things because the very same milkmaids were also infecting their own family with cowpox, and they themselves continued to work. And so what he noticed is that up to day 8 to 9 or 10, uh, they were still infecting. In other words, the children could get infected from their mothers, their relatives could be infected from them. But after the 14 days, this was no longer effective. So something occurred. There was a change there that occurred in the system. Uh, and so the idea was to observe now whether, in fact, uh, these people were protected from another infection. So he deduced from here that they were protected after day 9 or 10, and definitely after the day 14. They were protected from reinfection with cowpox, which is very interesting by itself, but from the patients themselves and listening to them very carefully, he also noted that the same patients that already acquired resistance to reinfection by cowpox, they never contracted smallpox, although that was endemic in those areas and popped up from time to time. So the question was, is it true what people were already believing in that area, that contraction of cowpox will protect them from smallpox? And this is the thing that he needed to prove, and he needed to prove that experimentally in humans, which at the time was not at all a practice in medicine in general. And definitely in a case where the origin of the disease wasn't even known. At the time, people thought the disease came from miasma, but definitely not from a specific pathogen, be it viruses that were never even thought about it, or bacteria that already were known since the time of Leeuwenhoek, but nobody knew at that time until Pasteur showed that it could also be pathogenic. So he decided to design an experiment. And this was a very interesting experiment, one of the first clinical experiments being done, although not fully controlled, as you can imagine. So his idea was this time not to take directly from the cow, but to take from the person who already contracted smallpox, part of the fluid of the pus, and inject it into another person and see whether this person will contract also smallpox, which he did. So that was an experiment done that occurs also naturally. But the other question was this person also now resistant to reinfection after 14 days? Or even more important, were you also resistant to what's called variolation? Variolation is taking the contents from the pustules of a smallpox patient. That was already a technique quite used for a good number of years in England. It was imported, in fact, from Istanbul, but it originated all in India, from India to China, and from China all the way to Istanbul. And the variolation was simply taking the same thing as it did here with vaccination, but taking it now from the person who contracted smallpox and injecting it into another person. And normally, what you will get is this type of reaction, indicating that this person was infected. But this was done in a very minor way, so the person still had time to develop immunity against it. So during these 10 to 14 days after violation, what you were going to observe is something of that sort. If that person reacted to this pathogen. But if the person already acquired resistance to smallpox, to cowpox, and also to smallpox, you will not observe that because it's already protected for both. So this was the concept that he had without knowing, in fact, what was the basis for it. Why? Only in 1956, in fact, it was demonstrated that cowpox and smallpox are caused by viruses from the same family, the so-called the orthopox family. So the question was now, all right, if this is the case, what will happen is that if a person contracts small a cowpox, then he will develop antibodies that are going to share common properties with antibodies that the person that gets smallpox. And so, therefore, you could use that as an indicator of whether or not a person acquired immunity, which was actually trying to answer this question here. So, use basically this diagnostic tool to understand whether one particular disease or another one was contracted and whether one could prevent the other. And so, in fact, by the way, the so-called cowpox was not true cowpox. The the pathogen, the virus, in fact, seems to be closer to a horsepox that for some reason also infected the cow. And the cow, did not have really serious symptoms except those poxes that they showed. Now, the crucial day arrived. He was waiting for that day to do the clinical experiment when a lady by the name of Sarah Nelms, who he knew very well, she was usually a very healthy person, had no other diseases, and the cow from where from whom she got the cowpox was named Blossom. Both are very important in the history of immunization because from that particular person, he decided to now vaccinate the boy called Jenner. Why did you call that vaccination? Because vaca means cow. And so vaccination is originally some treatment that using something from the cow that was the originator of the disease. So now the vaccination was done, or the inoculation was done on a boy, and a naive boy of 80 years old, whom he knew very well because he was the son of his gardener. Why didn't he use him himself or his own children? Because he himself already had smallpox when he was young, and he assumed that his children also had it. And in any event, this boy was supposed to undergo variolation. So he decided to precede the variolation by doing here the vaccination and to see what will happen with variolation. So he waited for 14 days and he developed the pustules here. But then he had to wait for another 6 months until a smallpox erupted in his area and he could mobilize some of the patients and take from them their contents, which he was going to use anyway in order to immunize, as we know today, this boy. It was a common practice. It was a very dangerous one because many of these people had also other diseases like syphilis or tuberculosis. So it was kind of risky to use any person for that purpose. So he was very, very careful in choosing the person in order to inoculate for the second time the boy James Phipps. So there were two possibilities after this kind of variolation. Either he will develop the kind of symptoms that person will be getting or will be manifested in them if he didn't have any previous experience, like in this case, or nothing will show up. So if nothing will show up, it would mean that the person is already immunized against the variola or the smallpox. So that's what he did, and the answer was negative. In other words, this pre-treatment with the cowpox prevented from contracting smallpox. But this was one time, and he needed to do it with many other donors of the smallpox, which he did. And he repeated this 20 times on the same boy. So the same boy became his guinea pig. But after this repetition, he was absolutely certain that the guy was immunized. And this methodology that he used was useful and very protective. And essentially, we could say today with quite some certainty that this was the beginning of vaccination. This was the absolutely new concept and new treatment, but he had to prove it. This was only one patient. Now, he presented his data before the London Royal Society. The Royal Society was very demanding. Their motto is nullus in verba. Here, your words are worth nothing. You have to provide evidence. And his evidence was kind of bigger. And he said, well, they said to him, this is a wild idea that is at variance with established knowledge. And what was the established knowledge? It's the question. Well, not very much. But the questions that they raised, I think, were very important because uh, they asked him questions that he could not provide the answer. It took many hundreds of years before the answer was provided, like why the pathogen against cow will prevent the human disease, or why, or which is the pathogen altogether, when they thought at the time, according to the old uh, dogma, that it comes from the asthma, from the air, from the environment. And then, of course, very practical ones. And this is how many experiments did he carried out, and did the sample from the poster remain infected for how long, and many others. And another, by the way, very important one is it safe? And is it safe for children? And why did he choose children? He could provide some of the answers for why he chose children, because the children are naive, and if they're going to be the donors or the carriers in future experiments, he wanted to have children of people who had no other diseases before, or not record of any other diseases. And he published this work by himself after 2 years, after meticulously answer all these questions that they posed to him in the Royal Society, except the two first ones, the nature of the pathogen, that he had no means to know that even they existed. So he published this work as an inquiry into the causes and effects of the variola vaccine, and of course the treatment. And it's an initial requirement. He published that on his own, by the way. It was printed for the author, he paid for it. And he referred himself as a fellow of the Royal Society, which he was. He was a fellow, but not because of his MD that he got from a Scottish institution, by the way, this titular of MD, and not from London. Was not considered at the time a Scottish institution of the same caliber as London. But he was a fellow because he published already many studies on behavior of birds, and that this was his hobby. And he was especially in that field, and for the publications that he had in this area, he got it to become a fellow of their society, but not because of his MD. And in any event, the society scrutinized everything. Uh, doesn't matter the origin of the person or his titles. Now, what is important was he said here, because this is a breakthrough in science and in medicine as well. And he quotes here Lucretius Carus from the Rerum Natura on the nature of things. And he quotes this saying, what is more certain than our senses to tell false from truth? He found that his results were absolutely true and not reproducible. He repeated that initial experiment on 10 other subjects, including his people from his own family. And in all of them, he observed all or none type of results. So it was absolutely certain that he had some truth behind, and not the false type of speculation that they had at the time in general regarding infectious diseases. And this is important because it's a change in thinking in general, using what we think is the scientific reasoning, which he had, although he had no control experiments here. But nonetheless, this was a major breakthrough that he could already prove, because this became a practice almost immediately after the publication. And in one of the places where it was applied outside the England was in France, initially by a doctor from England who traveled to France. And in the first stop, crossing the La Manche in Boulogne-sur-Mer, he inoculated three sisters, and the rumor spread immediately. And obviously, it reached Napoleon, who immediately adopted this vaccination to his army, later on, even by imperial decree to the entire population. And so vaccination slowly became mandatory in different countries at different times. And in the UK, Ironically, surprisingly, but maybe not, only 50 years later. And that's really a big question mark. Why? Now, a lot of this success had to do with this translation of Jenner's paper or treatise and by Louis-Jacques Moreau de la Sarthe, and he essentially expanded the original observations made by Jenner to already what has been accumulated in the next 2 3 years, and published that in a book that became classical and disseminated all across Europe. And look, interesting enough, the one who translated to Spanish was Francisco Balmis, who was the head of the philanthropic mission to South America. And it took, in fact, 500 copies, not of this original, but of its own translation of the book by Moreau de la Sarthe. And it's important because here you have not only the history, but also the practice of the vaccine that was already accepted as the way to describe the origin of the medicine. And here, importantly, Jenner himself already predicted, and almost as a prophecy, that uh, this most dreadful scourge of the human species could be eliminated. And this should be the final result of the practice, namely of the vaccine, to eliminate it altogether from the earth. And this is, in fact, the first step towards that was this philanthropic expedition to South America. So this expedition that started in 1803 in the port La Coruña, after a small stop here in the Canary Islands, they crossed the ocean all the way to Puerto Rico, reaching it at the beginning of February, and then splitting to the north and to the south. And eventually, a group from the north also is going to be crossing the Pacific all the way to the Philippines, cover this entire area, including part of the Southeast Asia. And eventually, after 3 years, returning back to La Coruña. Now, obviously, the 22 children that originated in La Coruña were not the ones that followed or continued. Now, the vaccine that reached Puerto Rico, now they mobilized local people from local orphanages or from families that donated sort of their children, and they were the carriers. They were the carriers in the terrestrial part as well as across the different oceans. And more than 100 of those infants took part in the project. And they considered to be the big heroes of this particular philanthropic journey. And more than 100,000 people were vaccinated by this technique from arm to arm. That was the only technology available at the time until they found a way to preserve it a little better, but that took some time. So it's an incredible enterprise that they had, that they made. And Jenner himself said that he cannot describe in human history a more philanthropic journey. And Humboldt himself claimed that this journey will be remembered as the most admirable of all, at least until his time. Now, the technique that they were using to vaccinate was extremely simple. With a sharp knife, there were different sizes of them. Sometimes they had like a three-blade ones, and they adopted it from the Indians and did not adopt it from the Chinese, who were essentially blowing it into the vaccination into the nose. This was the safer method. This was never adopted in Europe. And we can see here some of the things which were used in different years to different people. For the aristocrats, of course, was different from just simple people. And with the years, it became more and more sophisticated. In 1902, for instance, the whole kit was used here, together with the needle and the vaccine in the test tube. But the one that we used mostly was this particular one, this two-blade, very tiny knife, if you like to call it this way. This is the form. That was used only for vaccination. And in fact, almost 90% of the world was vaccinated with this technique. Later on, two brave women who were the first one to take to be vaccinated. The first one was essentially violated was Catherine the Great, and the other one was Maria Fyodorova, who was vaccinated. And their family, and the court were among the first one that tried that. Interesting enough, the first girl in Russia that was vaccinated was later on, her name was changed to Vaccinov, and the whole family changed the name to Vaccinov, just to prove how important that he was. Important personalities that contracted and overcome smallpox were Mozart, Beethoven, very clear signs of it in the sculptures, Lincoln, and one of them that always tried to hide it, with special shades when taking pictures, was Joseph Stalin. In 1967, the WHO decided to eliminate completely smallpox from our planet. So here we are talking, look how many years after this thing that originated with Jenner. And they did it not with the same vaccine that Jenner used. They used now a different one from a virus called vaccinia that belongs to the same family of orthopox viruses, but is much safer and can be grown also not necessarily in humans, but can be grown, for instance, in eggs and other media. So this became the standard, which has been used for covering the entire world. It started in 1967, a world campaign, and completed in 1979. And from 1979 to 1990 was not a single case of smallpox in the world. And so the WHO declared that smallpox is finally dead. There are two big reservoirs of the viruses, one in the CDC and the other one in Russia. In case this erupts again, they should have at least some source to produce as fast as possible a vaccine. Now, finally, with respect to the story towards the end of it, how was Jenner honored, or wasn't properly honored? Well, the first to honor him were the French, and and in fact, the Jubilee, being 50 years after the first vaccination, they already had here a big ceremony. This is general sculpture, simply remembering how the story of the three girls in Boulogne-sur-Mer were vaccinated by this Dr. William Woodville from London. And Napoleon, of course, it's also written here that Napoleon adopted that relatively fast and made it compulsory to the army. Now, every year there is a special ceremony, banquet, fireworks, and etc. And interesting enough, Napoleon himself praised a lot Jenner. In fact, when he was asked by Jenner specifically, he got a petition from him to release some uh, uh, English people who were captured by the French. They were at war at the time. And he made this gesture. He said, "Oh, to Jenner, that man I can't refuse." I wouldn't say that the English were as generous with him as Napoleon. Only 50 years after his death, we are talking about now, so much later, and they essentially, Queen Victoria decided to pay homage to him, and they placed a statue of uh, Jenner in the Trafalgar Square in a special ceremony there that was inaugurated in 13 by the prince, by her husband, the Prince Edward. And this event was 3 years after the parliament itself made vaccination compulsory in the UK. And that created a tremendous reaction in the population. I'm talking about the sculpture here that was, or the monument that was placed in the Trafalgar Square, because the veterans of the Horse of Guards and the reality, they were scandalized just of the idea that a simple doctor, even, from a country doctor, should be placed together with distinguished, in the company of this great people. Not only that, but he was in the sculpture, he was sitting, whereas all the soldiers had to be standing there. So that was for them considered an offense. The uh, the news there, the papers that were also not terribly supportive. But they showed that the problem that many of the families had, on the one hand, mandatory to vaccinate children, but on the other hand, being threatened that those may die because of the vaccine, or they may grow horns, all kinds of faces, because it was originated from the cow. The parliament rejected it altogether, and as you know, it was established, but still, there are demonstrations from time to time against vaccination. Well, all that didn't help very much because the monument had to be moved, and it was moved. It was moved from Trafalgar Square to the Kensington Gardens, where it's until today and very well kept. And uh, and this is the story there. But these kind of gestures, sort of quote gestures, by the Parliament are not very flattering to the British in the sense that it took them for a long time to decide to provide him with a some sort of a uh, help, let's say, like by giving him a grant or a fellowship. But he finally did it, and that happened only 2 years before his death. He all this money he in fact transferred to the boy Phipps, James Phipps, and it helped him also building his own house and the garden. So he did not enjoy very much any rewards from the parliament. And the parliament didn't act also very honorably when they refused to have a state funeral at the Westminster Abbey on the grounds that it was just simply too expensive. So at the end, he was buried in his own town, in Gloucester. And here what we have is also a statue of a general in the Gloucester Cathedral. There's a big discussion going on whether or not was Jenner the first one to discover vaccination. Well, vaccination for sure, but variolation itself was brought to Europe by a lady, Mary Wortley Montagu. Now, this lady was the wife of the British ambassador to the Sultan in Istanbul. And she mingled a lot with the local people, including the women and local doctors from whom she learned about variolation that was already implemented there for quite some time, and claiming that they did not suffer from smallpox in those areas. So she decided to inoculate or to variolate her child, and when she came back to England, to the other child, and also they tried to persuade the court to do it, and eventually she managed to convince the princess and have her children or the grandchildren of the king, violated. Only after they tried violation on some inmates in one of the jails there, and proved that it was effective. And that was also adopted later on by doctors, but not by too many in the country, realizing that also there were many cases that people contracted other type of diseases due to the fact that the carriers were not always healthy people. With regard to vaccination per se, there was a person who did vaccination on his own initiative. He was not the only one. There were other cases that he moved to an infected area and had his children touch the cows and get infected. Uh, and in fact, in this way, he protected them from smallpox, even with his own family and some relatives. But again, all that remained in the domain of the family. It never really spread too much beyond that. And so what we can say here that for sure, the guy who needs the credit is the man who convinces the world, and not the person who had the idea first or shown that first. Because proving something is one thing, saying something is a totally different thing. And I think that what Jenner had is a proof, and although not fully original, but definitely uh, it was a major breakthrough in general, both in science as well, and particularly in medicine. And the irony of this is that Jenner hit the target that he didn't see at all. That was the variola virus. But neither did Pasteur many years later when he hit the cholera in animal cholera or rabies. He didn't realize even there were even viruses at that time. With cholera, they knew there was a bacteria, but he never really followed that bacteria. Now, essentially, when we look at this, those people had no clinical essays to identify the disease, but just a visual examination of what we call external symptoms. And the external symptoms were used in a very intelligent way as a diagnostic tool to prove whether or not the treatment was efficient. And in fact, this was a major breakthrough in medicine, with absolutely no doubt. So, are we here talking about the genius that hit the target no one else can see? Okay, that is one definition. You may have others. Now what I want to show is how diagnostic tools are lifesavers and in a very particular conditions, very unique ones. And we talk about a disease that affected the European history for more than kings. And I'm talking about typhus. So that is a very severe disease. It has very different names. The perpetrator of typhus is a bacterium. The bacterium is the Rickettsia prowazekii. Those are the names of the two people who discovered it, Ricketts and Prowazek, von Prowazek. But the carrier of this bacteria that delivers it to humans is the body louse. So louse is the singular for lice. Even the word lousy comes from louse. You feel lousy. Now, the interesting part that's what we're referring to because of curiosity in a way, no, and also worth knowing is that the Nazis had a nightmare regarding lice. They knew very well what this can cause. They knew it from World War One, but also from history, because they knew exactly why Napoleon lost his famous campaign to Moscow, with more than 90% of people dying from typhus. Already at the time, there were many more people dying during the October Revolution than from other reasons. In World War II, more than 25 million people died from typhus. Even in concentration camps, it was the main cause of death of people there. And all throughout history, we have many more examples of that. Now, here comes the interesting part of the story, how a diagnostic test developed for typhus by these two physicians and microbiologists, Felix and Weil. So it's called the Felix-Weil test. And I call it a lab test for all seasons. Between World War One and World War II, it was essentially the only, let's call it objective test for identifying typhus as compared to other diseases. And what was the test that they developed, which is very, very interesting? Okay, it's a very simple test that, again, was the major one for close to 30 years more. What Felix and Weil discovered was another bacterium called Proteus vulgaris, shares some common properties with the Rickettsia, which is the bacteria that causes typhus. This is very similar, if you like, to what we talked before, smallpox, that is not very pathogenic. Sorry, cowpox, that is not very pathogenic, like Proteus vulgaris, is not a very pathogenic bacteria. And Rickettsia, that is very pathogenic, or smallpox, that is very pathogenic. So smallpox and cowpox have something in common, and so do these bacteria. What they have in common is some proteins on their surface, meaning that a patient that had typhus, let's say patient A, he will develop antibodies against the Rickettsia. But these antibodies, most likely, some of them will recognize also Proteus vulgaris, because both bacteria have this component in common. So what they design is a simple test. So if they take a suspension of bacteria, Proteus vulgaris, non-pathogenic, and they mix it with antibody, now in this mixture there will be a reaction, and the bacteria with the antibody will sediment, will simply agglutinate and precipitate. How will this show up? Okay, mixing here the two. Well, if we have a initial suspension of bacteria that is very turbid, and this is a suspension of the serum from a patient that is very clear, and we mix the two, then at the end what we are going to get is precisely that. Oh, for some reason the mouse, okay, here. So we are going to have this very clear result, the test tube which is very clear, and the precipitate here at the bottom. So this simple test was used. In fact, it can be quantified. This is just a visual representation, but this can be quantified with simple machines that measure turbidity. And this was used for many, many years in laboratories to identify typhus. Now, what happened in 1938 is that the Germans invaded Poland. They split Poland in two parts, one part to Russia. They invaded this, the eastern part, Ukrainian part. And then something interesting happened here in this little town of Rosvadov. So these two physicians, very clever people, didn't want to have the Nazis entering into their own village. They wanted to protect their people, to protect the Jewish people, to protect partisans, knowing that the Nazis were not entering into a village that is contaminated with a typhus. They decided to immunize the entire village with the non-pathogenic Proteus bacterium. So they will develop antibodies against this bacterium. But in terms of diagnosis, it will be the same as though they have typhus, which they didn't have. So all the serum from these people were sent to central laboratories in Warsaw that was supervised by the Nazis. And that's what they discovered, sort of, discovered that they were, the entire village was positive. So positive for them, it was typhus. And so they declared Rosvadov as a typhus infected zone and forbid was forbidden for Germans to enter unless they had a very special permission for it. Now, Rosvadov was also a very important train junction from where many of the trains were moving to the east. So they had to move the station and all the rest. It was a major ordeal for the German army as well. And this, the two doctors succeeded, but the plot was discovered in the end of 1943. Fortunately, they were told that the Germans became suspicious why they had so much typhus there and not that many people were dying. So they managed to escape on time and they lived underground until the end of the war. Now, these two people immigrated years later, one to the States, the other one to Zaire. Both became professors, one in pediatrics, the other one in radiology. And they never disclosed what they have done to anyone except to their own family, to very close family. So the story was kept until 1990, essentially in secret. But then they decided to publish it because they were already retired. So also, in case they would be sued for breaking the Helsinki law or the Hippocrates, then at least they were certain that they were now protected in a way. And 10 years later, the town of Rosvadov that was paid notice to this and decided to also pay them homage in a special meeting in their honor where they told the entire story, and the people were surprised. Until then, they were most of them thinking that their parents or grandparents were saved by by being inoculated or immunized against typhus. Well, they told him, well, not quite typhus, something similar. So an interesting part how they are using here a diagnostic tool simply to fool and save the people. Of course, they have done nothing wrong except expose them to something that uh, was innocuous, sort of innocuous, that they caused only minor symptoms. A lot of this story, by the way, is being told by in a book in the so-called night trains. But now I want to move from the west to the east, where the Nazis invaded in 1941, and we are concentrating here about the town of Lvov. And some of the story you can read also in this interesting book. It's highly dramatized about what happened in this fantastic laboratory of Dr. Rudolf Weigel. Now, 1 or 2 points. The lice were discovered as the vectors of the disease, and a year later, the rickettsia as the actual bacterium that causes that disease itself. But one of the problems is it was very difficult to grow the bacteria, also difficult to grow the lice, and to make them in such amounts that they can also produce now a vaccine. So they needed both of them, and there were not good techniques for that. The bacterium like to grow only in the gut of the lice, and the lice like to feed only on mammals or human blood. So everyone was desperate to do it in large scale, and no one had really a good technology for doing it. Now, what was different in the case of this laboratory in Lvov headed by Rudolf Weigel? He went to the very simple way, but very tedious. And he succeeded in developing essentially both an anti-typhus vaccine and also indefinite in amount that it could really be applied to a large, relatively large population. But he was using the bacteria and the lice, growing them in their natural environment, meaning that the bacteria in lice and the lice by feeding from blood. So when the Wehrmacht, in fact, already after the invasion of Eastern Poland, they took over the Weigel's laboratory and forced them to produce a vaccine for the ESD, for the German army. But Weigel told them that he needed to have a lot of people for this. They could not understand why. He wanted to have a number of people because this was based on the technique that he developed that was extremely, modest. And I will show you what was the technique. Essentially, he grew lice in matchboxes, and the matchbox was covered with a net. And through the net, the lice could also suck blood from people. So those boxes were placed with a special belt here on the legs of a person. And for 25 minutes, the lice could get a very nice meal and grow nicely there. And by the way, one can see the entire methodology, if you like, in a movie that was made by the Polish people, years after the war, reproducing exactly what happened. So the lice that are now quite happy and satisfied after having a big blood meal and been reproducing. So now they are placed in this kind of multi-clamp device, and they are injected one by one under the microscope with a little capillary with bacteria, rickettsia bacteria. So until now, everything was in a way sterile from bacteria. So now the lice themselves get infected. The bacteria goes into the digestive tract, it reproduces here, and at the end, the lice also die from the number of bacteria that reproduced here. So the gut is being removed and sloughed, and the bacteria are killed here with the phenol, and that's what's going to be used now for immunization. That's what it is. Now that's the reason why he needed so many people, more than 4,000, who all of them were safe and also relatively good conditions compared to others. But the best they can do is something like 2,000 vaccines per month, which was very little for the size of the armies that needed it. And obviously the test was the Felix Weigel test. Now, what was nice about Weigel is that used all the people there were volunteers, and used some of them also to smuggle an active vaccine to partisans in the Jewish in the ghetto, and also to Jewish people as well. On the other hand, what he sent to the German army was mostly a vaccine that was inactive, and that didn't help him very much because when the Russians arrived, they prosecuted him for collaborating with the Nazis, but he was not convicted at the end. He was nominated 3 times for Nobel Prize, twice for medicine and once for peace, not granted. Yad Vashem honored him in the Garden of the Righteous. Of course, in Lvov, a special statue in his name. There are fellowship and institute in his name. And one of the great things that he also done, he was also the advisor of Ludwig Fleck, born in Lvov. He died in Nestiona. And Lvov, Jewish person, was put immediately in the ghetto. And in the ghetto, he developed his own vaccine and a diagnostic tool, also using the Felix Weigel test. But the Germans that knew about it immediately mobilized him. They moved him initially to Auschwitz, to a laboratory, and later on to another one in Buchenwald. And he headed a relatively large group there of convicts, political convicts and prisoners who actually were part of a team that had to develop a vaccine and provided the vaccine to the German army. So he added that because his previous experience, and the Germans knew about it very well. Uh, but he had to join the group there because what they were producing there was a fake vaccine. And he had to essentially prove or disapprove whether it was positive on the Felix Weigel test, since the vaccine was tested, in fact, on inmates in Buchenwald itself. A serious problem for him. But they didn't want to participate and collaborate with the Nazis, knowing that the people anyway in Buchenwald would be liquidated one way or the other. Now that caused later some problems for him. Interesting enough, in the Nuremberg trial, Fleck was accused by the officer who headed the project at Buchenwald for providing him with fake data, fake results, that in fact the officer used in order to submit and it got eventually a PhD thesis, all based on fake data that was obtained at Buchenwald. And interesting enough, it was Fleck himself that helped him write the dissertation. So that's one of the ironic parts in the story. Now, Fleck survived the Holocaust and later on assumed several positions in Poland, in Lublin, and then in the Polish Academy. And he joined finally the National Biological Research Laboratory in Nestiona when he immigrated to Israel in 1957 and died in 1961. But he's very well known, not so much for his contributions in microbiology or clinical microbiology, but about his pivotal work in the field of the psychology and sociology of scientific thinking. He's considered to be, in fact, the father of this field, that he essentially was very active during the early years of his career, but obviously the Holocaust, he really couldn't do very much, and he didn't pursue that part at all later on. Thomas Kuhn, who wrote the preface to the translation of his book from German to English, essentially based a lot of his theories on what initially Fleck developed and published in this book on the development of a scientific fact. So this is the story which I want to tell you and leave you for further consideration to think about whether one can justify using false data or falsify them to save lives, probably, or for affecting your enemies differentially under codes such as in the war is like a war. So if you have to fool another person using medical data, which is faked, it's a big problem in terms of medical ethics. And the question is, what comes first? And that I leave anyone in the audience to decide by himself. So thank you um, for listening to this talk, and goodbye.